Okay, so the next example is going to be about the welding travel speed. Now, the only equation that we have in the slide that we supplied to you, unfortunately, was missing something, which can be found later in the section 30. So we have that the unit energy for the melting is going to be equal to the K multiplied by the Tm square. The K is a constant that equal to 3.33, and the unit for the UM is equal in joule per cubic millimeters. Tm is the melting point of the metal in Kelvin. And sorry for that. And we have the K value, which is constant. We said 3.33 multiplied by 10 up to the power minus 6 when the Kelvin scale is used. So the value for the absolute melting temperature for the selected metals can be shown in the table 29.2. So different materials, we're going to use the Kelvin 1 and to use the value for the K to be 3.33 multiplied by 10 up to the power minus 6. Now let's have an example on that. So the equations, once again, that's the UM equation, and that will be the velocity equation. Mainly the power, okay, the power is energy times velocity, and that's what we have. Actually, I can say that the power is equal to the velocity multiplied by the UM multiplied by the area. Okay, so that's joule per cubic millimeter, that's millimeter square, and this is millimeter per second, and this will be being joule per second, which is the watt of the power. Anyway, let's read the question here. We have a power source that in a particular welding setup they have 3,500 watts, or we say 3,500 joule per second. That's going to be transferred to the work surface at the heat transfer factor of 0.7. The metal to be welded is low carbon steel, okay, whose melting temperature can be found from the table 29.2 is 1760 Kelvin. The melting factor of the operation is going to be 0.5. A continuous fillet weld is to be made with a cross-sectional area of 20 millimeters squared. Determine the total speed which the welding operation can be accomplished. Now we need to find the V here. What I need is going to be the following. First is going to be the area. Second, I need to calculate the UM. So I have the Tm given to me here. Tm square multiplied by 3.33 divided by 1 million. Done. So what I'm going to do is I'm going to get my calculator and start to do the steps to calculate the power before I'm going to show you the answer. So now we have to calculate the UM. I have 1,760. I will square that. I will divide by 1 million. 1, 2, 3, 4, 5, 6 equal to 3.09. I'm going to multiply by 3.33 equal to. Now I have 10.3. That's joule per cubic millimeter for the UM. Now the UM multiplied by the area, 206.3. That's what we need to put here. Okay. Now I'm going to reverse that and multiply by 3,500. So the velocity is going to be 17 millimeter per second. That will be the velocity. Okay, now let's go back and check the answer. So the step number 1 is calculate the UM, 10.3, the same answer I got, and then again to calculate the velocity, 3,500 joule per second divided by 10.3 joule per cubic millimeters multiplied by 20 millimeter square. So again, to remove 2 from here, I'm going to have the millimeter square to be done, joule with joule, and the answer is going to be 16.99 millimeter per second is the velocity. Okay, that will be the second example, and we're going to go to the third very soon.